All right, here we go. So this is 4.7. This is our day 2. We're up to Roman numeral 4. So this part is just using the calculator. I believe we went to our settings and kept it in radians. So you should be absolutely fine because all of these are, I want radians for inverse. So what I'd like you to do is just make sure you can use the buttons on your calculators. So inverse sine of 1/4, and this says go to 4 decimal places. All right, so then try the rest of these, okay? Use your calculators. You know where your trig button is on the left side? And then instead of doing the top row, which is sine, cosine, tangent, you're going to be using inverse sine, inverse cosine, inverse tangent. And again, go 4 decimals on here. Anybody need help with their calculator? Yeah. Okay, check. Go back here. Go to your settings.
I don't know.
Yeah, so now these should all be in radians. There's no degree symbol. And go down to make default though. There you go. Yeah, you guys, do you notice? I mean, there's no degree symbols here, so it is radians. All right, Roman numeral 5. If you remember from Algebra 2, if 2 functions are inverses, then f inverse of x equals x, and f inverse of f of x equals x. So in letter A, when I have cosine of inverse cosine of 0.6, I want to kind of break this down to show why this works. So this inside piece means the cosine of some angle is 0.6, or 6/10, right? That's what the inside means. So watch this. If I draw a right triangle, and that's 6/10, so let's call it 6/10, this answer is an angle, okay? What's inside here, that whole thing is theta. So then when I go to do cosine theta, isn't it 6/10 or 0.6? So essentially, and there's just one qualifying piece. So when I do cosine of inverse cosine, it's like they knock each other out, except it has to be defined, and the inverse has to be, for inverse cosine, has to be between 0 and pi. Inverse sine, inverse tangent have to be between negative pi/2 and pi/2. So just don't go motoring along with this. We got to be careful. So, because here's the deal, like my answer in letter B is not 3pi/2, okay? Because inverse sine can't be 3pi/2. So what I do is I go nice and slowly with these. What is the sine of 3pi/2? -1. Then the inverse sine of -1 would be -pi/2. So, you can, it's just a little bit dangerous to think you just cancel them because you've got to be careful with where the inverses are defined. Like what we mentioned yesterday is inverse sine, inverse tangent are defined -pi/2 to pi/2. Inverse cosine is 0 to pi, so just be careful. All right, let me pause and I want you to try C and D. Don't use a calculator, okay? So shut the calculators off. We only needed them in example 4. We don't need them again. So letter C, the sine of 0 is 0. Inverse sine of 0 is 0. Okay, now what's up with this one? Do you remember when you do inverse cosine, the inside has to be a number between -1 and 1. So this one is not defined, or you could say undefined, not possible. Don't say no solution because it's not an equation. All right, when you're ready, flip the page, and you might need to think about that one a little bit further. The inside of sine and cosine have to be between -1 and 1. Then the outputs for inverse sine are -π/2 to π/2, and the outputs of inverse cosine are 0 to pi. All right, so let's look at example 6. Again, we're not going to use a calculator. It says find, and anytime you see exact value, that's a no calculator situation. So it says we want to find the cosine of inverse tangent of 5/12. So the inside is an angle. So I'm going to play the game, what do I know? And I know that if I have inverse tangent of 5/12, that means the tangent of theta would be 5/12. So let me draw a picture here. Put theta, and that's 5, and that's 12. Does anybody remember your Pythagorean triple with 5, 12, 13, okay? So this is a common Pythagorean triple, so I can find the missing side without a calculator. So now, what is the cosine of that angle? Look at the triangle. Here's theta. You're using SOHCAHTOA. So what's cosine of that angle? 12/13. All right, so this is pretty cool. This is pretty cool what we're doing. So let's look at letter B. I have the sine of inverse tangent 3/4. So I play the what do I know game. So math is so fun. So here we go. The inside is theta, and I get the tangent of theta is 3/4. Like that's what I know. So I'm going to draw a triangle. TOA, tangent, opposite over adjacent. Then what's my missing side? 5. It's a 3, 4, 5. So then what's the sine of that angle theta? 3/5. Okay. All right. Is this starting to make sense? So we're just going to ratchet it up just a little bit and go to example 7. And it says find the exact value. That means don't touch the calculator. And I want to do the cotangent of inverse sine of -1/3. Uh-oh, I have a negative in there, and it's inverse sine. So where am I located? Fourth quadrant. Okay, so you can either put it in the fourth quadrant, or you can just draw your triangle and know that's fourth quadrant. However you want to roll is absolutely fine. So what I know with the inside is that's theta, and the sine of theta is -1/3. So I'm going to put theta to the x-axis. It's 1/3, and the negative has to go with the down piece. All right, so we're going to have to use the Pythagorean theorem to find the missing side, because I need it.
But you don't plug -1.
Right. I mean, yeah, because when you square it, it'll be positive anyway. But yeah, okay. So if I do a squared plus 1 squared equals 3 squared, that's the square root of 8. We always simplify our radicals, and I had students who misunderstood when I said don't rationalize. They didn't simplify the radical. I just said you don't have to rationalize, which that's, I can leave 1/2, but I can't leave a square root 8 anywhere. Okay, there's a difference. So that's what, 2 square root 2? Okay, 9 minus 1. So then, what's the cotangent theta? Well, then that'll be the adjacent over the opposite, which is -2 radical 2. All right, I'm going to pause, and I want you to try letter B. I'm getting radical 3 over 2, and it's positive. And doesn't that make sense? Because the cosine of an angle in the fourth quadrant, all students take calculus, is positive, okay? All right, what questions do you have? What questions can I answer before we do the last two? Notice these are compositions because I'm putting one function inside the other. All right, example 8 and 9 are the same. I just thought I'd do one and then let you practice one. It says if x is between 0 and 1, write cosine of inverse sine x as an algebraic expression in x. So watch this. It is really the same thing as what we were just doing. If I take the inside, the inverse sine of x is theta. So this means the sine of theta is x, or let's say x over 1. So let's draw a picture here, and that's x over 1. I can find the missing side. If I call it 1 squared equals x squared plus, I don't know, b squared. So if I then solve for b, that's 1 minus x squared equals b squared. So b is the square root of 1 minus x squared. So then the cosine of that angle would be the square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared. Now, why do you think I put a qualifier of x is between 0 and 1, now that you look at our answer? Why do I have that? You can't have a negative under the square root, okay? That's all. All right, so now you guys try example 9. This one says if x is greater than 0, write secant of inverse tangent x as an algebraic expression in x.
We're not supposed to solve for x, we're supposed to solve for the other variable.
You're solving for secant of inverse tangent of x. So if tangent is x, or x over 1, that's TOA, opposite over adjacent, then a squared plus b squared equals c squared. So the hypotenuse is x squared plus 1. Then if I want the secant, that's the hypotenuse over the adjacent. So I get x squared plus 1.
Why is that x squared plus 1?
Yeah, why is that supposed to be root of x plus 1? And in the